Word problems add an extra challenge to solving problems because we have to look at the questions and decide what variables and numbers we need to use in order to solve the problem. Fortunately, many of these problems follow a very distinct pattern that we can learn to recognize. Values like speed and cost are almost always shown on the y-axis. Anything that changes or varies is usually on the x-axis. The items on the x-axis tend to be things like number of units sold or kilometers traveled, etc. As well, there is usually an item with a fixed value that is represented by the value b. Recognizing which items fall into which category is the first challenge in solving these types of problems. In this example, we have two video stores. One store, Galaxy Video, rents a game machine for $10 and rents video games for $3 each. For Less Video, rent a game machine for $7 and rent video games for $4 each. We're asked to write an equation that represents the cost of renting one video game machine and video games at each store. In each of these two scenarios, we need to rent a video game machine in order to play the video game. This is a fixed cost and should be represented as the b value in an equation y equals mx plus b. X is the number of video games that are rented. It is a value that changes or varies. Our slope is 3 because for every video game that is rented, the cost goes up by $3. To model the Galaxy Video Store, we can say that C equals 3G plus 10. The equation modeling for the For Less Video Store will be C equals 4G plus 7. With these two equations, we can draw up a table of values for both equations, and once the points are calculated, we can graph them and find the point of intersection. So here's the table of values for Galaxy Video. Here's the table of values for Less Video. Once these points are plotted, we have two lines that intersect at the point 319. This tells us that in a scenario where 3 games are rented, the total cost from either store will be the same, in this case $19. If you wanted to rent less than 3 games, then it would cost less to use the For Less Video Store. Anything more than 3 games, then Galaxy Video would be the cheaper option. In this example, we have a graph of the cost of renting 2 banquet halls. We are asked to describe what the point of intersection represents and for how many guests would either hall be cheaper. So with the way the charges are set up, for Hall C, it does not charge any upfront cost at all to begin with, but it charges by the number of guests at a fairly steep rate. Hall D does not charge as much for each guest, but it has an upfront cost of $1,500. So if you look at the point of intersection for Hall D, you see the y-intercept is 0,1500. This represents the cost, the upfront costs of renting the hall. If we look at where the lines intersect, we can see that the value is 150,4,500. This tells us that if 150 guests are invited, both of these banquet halls will charge the same amount, an amount of $4,500. So, if the guest number is under 150, Hall C would be the cheaper option. With more than 150 guests, Hall D is the better option. Here we have a second banquet scenario. We are shown a graph where the two halls would cost the same at the point 240. At this point, both halls would cost $18,000. With fewer than 240 guests, Hall E would be cheaper, and with more than 240 guests, Hall F would be the better choice. Again, looking at the y-axis, we can see that Hall E does not charge any upfront cost for renting the hall, but it does charge more per guest. Hall F, the y-intercept is $6,000, which tells us that even though no guests would be invited, the cost of renting the hall would still be $6,000. However, the cost per guest is considerably cheaper for Hall F than Hall E. And it's not until 240 guests have been invited that both will be the same cost. In this example, the intersection of the two lines represents the point at which the cost and profit of making pizzas is the same. The red line shows that it costs $200 just to start making pizzas. This might involve beginning costs like hiring employees and opening the restaurant for the day. The blue line represents the profit made. With 0 pizzas made, the profit is 0. Once pizzas begin to be made, you can see that money is quickly being made at a faster rate than the cost. It takes 30 pizzas to overcome the initial startup cost of opening the restaurant for the day. Once at least 30 pizzas are made, then the restaurant begins to show a profit for every pizza made after that point.